This video is a brief explanation of recursion in computer programming with real-world and mathematical examples. Let's get into it. So according to the Merriam-Webster dictionary, recursion is a computer programming technique involving the use of a procedure, subroutine, function, or algorithm that calls itself one or more times until a specified condition is met, at which time the rest of each repetition is processed from the last one called to the first. This is basically the long way of saying that recursion is essentially a loop. It takes a bigger problem and breaks it into smaller, solvable steps until it finds its base case, the last, most simplified step of the problem. Then, it solves the other step problems one by one until it can determine the answer to the first question. Recursion is hard to understand with just this definition, so let's look at some examples that help illustrate what recursion is. Recursion is easily seen in daily repetitive chores, like washing dishes. Let's say you're serving dinner, but your kitchen sink is full of dirty dishes, and you can't serve dinner until they are washed and clean. So you take each dish one by one and clean it, then stack it to the side of the sink. You do so until every dish is washed. Now, you take the plate from the top of the stack, the last one washed, and you put a serving on it. You continue to do this until the last plate, the first one washed, is given a serving. That's a recursive method for serving dinner. Another example of recursion is found in looking up the definitions of words. Have you ever seen a definition of a word use that same word in its definition? For example, when you look up the meaning of jumped, the result says the past tense of jump. So to find out what jumped means, you have to first look up the meaning of jump. This is finding the solution of the base case. Then, you simply need to put the two definitions together to find the answer to the question, what is the definition of jumped? These two examples relate back to recursion because they show the recursive process in action and explain how recursive methods work with examples that are easily recognized in daily life. Look around. Almost any situation that simply needs to be broken down into smaller steps is recursion, from writing out a to-do list to washing dishes. Recursion is also found in math, and the easiest way to show the recursive process in action is through a piecewise function. Let's walk through an example of one of these problems. The piecewise function we'll be going through today is f of x minus 4 plus 2 if x is greater than 10 and negative 7 if x is less than or equal to 10 for f of 25. Let's start by identifying all our pieces. The top equation, f of x minus 4 plus 2, is our looping method. We will go through this equation until we reach a value that meets our base case, a value of x that is less than or equal to 10. The solution of the function that satisfies the base case will equal negative 7, so if we have f of 3, it will equal negative 7. And lastly, we have our big ticket question, what is f of 25? Now, to solve the problem to get an answer to f of 25, we first need to plug in 25 in the top equation because 25 is greater than 10. We solve this to get f of 21 plus 2. We don't know what f of 21 is, but we can figure it out by plugging f of 21 into the top equation and solving to get f of 17 plus 2. Again, we need to plug this value into the top equation because 17 is still greater than 10. We solve to get f of 13 plus 2. We still can't solve this, so we plug 13 into the top equation and get f of 9 plus 2. At last, we have a value that satisfies the base case of being less than or equal to 10. Because 9 is less than 10, f of 9 equals negative 7. Now, we can take this value and plug it back into our unsolved f of 9 plus 2 equation, solving to get negative 5. Plug negative 5 into the unsolved f of 13 plus 2 equation and solve to get negative 3. Continue in this way until the last problem, the f of 21 plus 2 equation, is solved. Plug the previous value in, negative 1, and solve to get a final answer of 1. This problem uses recursion to find its solution. Each step is broken down until the base case, a value less than 10, is found, and then the previous solution is plugged back in until the big question, f of 25, is solved. So, in summary, recursion is a way of breaking down a large task into smaller, bite-sized pieces that, once solved, will lead to the solution to a larger problem. I hope this video helped explain recursion and had some helpful examples that made it easier to visualize and understand.